Hello, grade 10s. Welcome to online learning. Today we're going to start with Unit 4. We're going to review a little bit about polynomials, and then you guys are going to learn multiplying binomials, which is new to you guys this year. So let's start with a little bit of a review from grade 9 here. So if you look at the top here, a polynomial is an algebraic expression made up of one or more terms separated by addition or subtraction. So let's see what you remember. Monomials, we know from last year, you should remember, represents one term. A term can look like, for example, 3x squared. Okay, that would be one term. Binomial, we know, is two terms. Okay, so we could have 2x squared plus 2x. That would be two different terms. We can't have two terms that are like terms and call it binomial because we could technically simplify them. So trinomial would be three terms. Tri means three. So we have 3x squared plus 2x plus 1 would be a trinomial. So all of those terms should sound familiar from last year. So moving from there, if you look at our warm-up, we're going to multiply some of these polynomials. So if we look at A, we have 2 times 3x. So 2 times 3 we know is 6, and the 2 doesn't have an x, but the 3 does. So we just leave it with a variable of x. Okay. Next one, if we look at our coefficients or numbers first, we have -4 times 5, which gives me -20, and we have one term with the x and one without the x, so it just stays as x. Okay, and C, we have, if you look at your numbers first, your coefficients, we have -6 times 2, which gives me -12, and we have an x times x. Now, we have to remember our rules for the exponent laws. If we have an x and an x, technically that shows an exponent of 1. It's not visible there, but there's an invisible exponent of 1. If we have x times x, it's like an exponent of 1 plus 1. Because remember, exponent laws, we add, keep the base the same and add the exponent. So 1 plus 1 gives us x to the power of 2 here. Okay, so we can apply that to the next one here as well. Move this over here. And we have 4 times 3, which gives us 12 here. If we look at just the coefficients, then we look at our variables. We have x squared and x cubed. So once again, we're adding the exponents, keeping the base of x the same, but adding the exponents. 2 plus 3 gives me an exponent of 5. Okay, so that should feel like a review from last year. Some terminologies that you probably remember from last year too. It's a common word used to describe multiplying a monomial by a polynomial is expanding. Okay, and then when we multiply a monomial by a polynomial, we use, and you guys remember probably this fancy word that we learned last year. Distributive property. Okay, so that's what we call the fancy word for expanding. And I apologize for the writing, still getting used to writing on the iPad here. Okay, so distributive property, you probably remember from last year, where we, for this example here, okay, the 2 is being multiplied by everything in the bracket. So we have 2 times x, okay, which is 2x, and 2 times -3, which gives me -6. Okay, so this is also a good opportunity if you want to pause the video. I'm going to go through all the 3 examples down here, but if you want to pause it and see what you know, feel free to pause it. I'm going to quickly go through the answers. But yeah, pause it and then you can press play again and go through your answers. So we have -2 times x, which gives you -2x, negative 2 times 9 gives you negative 18. Okay, next one, we have 3x times 7x. So 3 times 7 gives me 21, but then I have an x times an x, which gives me x squared because of that exponent law we had. Now we have 3x times negative 6. So 3 times negative 6 gives me negative 18. And just the 3 has the x there, not the 6, so I have negative 18x. My last one here, I have 5 times x squared, which gives me 5x squared. I have 5 times negative 6x. So 5 times negative 6 gives me negative 30s. And we see the x on the 6, so 5 times negative 6x gives me negative 30x. And then I have 5 times 1, which is positive 5. So we just can't forget that each and every term gets multiplied by the term in front of the brackets. Also notice that none of these are like terms. So I'm just looking for a color here. We'll use this. None of these are like terms. Okay, a like term would have to have the same variable and same exponent. So look at this one. Okay, I have the same variables but different exponents. Also, this is a good rule to highlight. Don't forget your exponent rules. Keep the base the same and add the exponents. Okay, that's what we did in this particular example. Okay, so on to the new stuff. Grade 10 stuff. Binomials, multiplying binomials. Now, a lot of the times we use the word FOIL to help us remember the process of multiplying binomials. And if you look at that, it just means first terms of the binomial are multiplied, and then the outside terms of the binomial, then the inside terms of the binomial, and then the last 2 terms of the 2 binomials. So I'm going to show you visually how that makes sense in this first example here. Okay, so we have x plus 5 times x plus 8. So x and x have to be multiplied by each other first. So x times x gives me x squared. The x also has to be multiplied by the 8. So I think about that first term of the first binomial being multiplied by each term of the second binomial. So we have x times 8 gives me 8x. So that first term has been multiplied by each term of the second binomial. The second term, which I see is 5, is going to be multiplied by the x, which gives me 5x. So that is the second term of the first binomial being multiplied the first term of the second binomial. And then we have 5 times 8, which gives me 40. So I showed you with 2 different colors because I wanted to show you that the first term of the first binomial is multiplied by each term of the second binomial, and the second term of the first binomial multiplied by each term of the second binomial. So now it's easy peasy. We put together like terms. So I've highlighted there the ones that are like terms, and we just simplify that. So I have 8x plus 5x, which gives me 13x. And that's your answer. So we're going to try a bunch more. If you haven't got in the groove yet, maybe you want to listen to a few more examples. If you have, good time to pause and try on your own. But I'm going to go through these quite quickly. If you feel like after a few you get in the groove, then pause and try some on your own. So I have x times x, which gives you x squared. I have x times 4, which gives you 4x. So I've done that first term. So 2 times x, which gives you 2x. And I have 2 times 4, which gives me 8. So your final answer, once you simplify these 2 like terms in the middle, should be x squared plus 6x plus 8. So yay if you got that right. Okay, next one. We've got x times x, which gives you x squared. We have x times 3, which gives me 3x. I I have negative 5 times x, which gives me negative 5x. And I have negative 5 times 3, which gives me negative 15. Once again, I'm going to put my like terms together in the middle there. And it gives me x squared minus 2x minus 15. Okay, yay if you got that right. If not, take a look at what you did wrong and fix the next one. Okay, so we have 2x times 7x gives me 14. Because I have x times x, I get x squared. Then I have 2x times negative 2, which gives me negative 4x. I have 1 times 7x, which gives me positive 7x. And then I get 1 times negative 2, which gives me negative 2. So I have 14x squared plus, if I put these like terms together, I get plus 3x minus 2. Okay, next one here looks a little bit different, but we actually solve it quite the same. So you'll notice that we have x plus 3 squared. That just means x plus 3. X plus 3 times x plus 3. They're just multiplied.